Hello. So today I'm going to be doing a live solve of a different approach by Dying Flutchman. And I'm starting with that, and you're going to hear that again in a second, and I'll explain why. This is actually future David, or Ranksk, whichever you want to call me. My name is David. Um, but I am from the future to tell you something about this puzzle. So the version of this puzzle that I solved did not have conflict highlighting on in the options for the puzzle. And that's because this is a somewhat older puzzle. It's like from September. So I don't know if that's old or not, but it's old enough that F-Puzzles did not yet have the cosmetic feature, which is actually a relatively new feature. So this puzzle does have something that looks like killer cages, and I'll go over the rules later, which is actually my earlier, but it has killer cages that mean something else. And so the conflict highlighting was turned off in order to prevent that from showing up red when you try to solve it. But the consequence of that is that if you repeat a number in a row or column or box, or you break some of the other constraints in this puzzle, F-Puzzles did not tell me about that. And so the consequence of that is that I'm going to warn you, I make several mistakes in this puzzle that I don't notice till later, and I have to undo and go back to it. So I'm warning you ahead of time. This is either going to be a long video or a video with a lot of fast forwarding. I haven't edited it yet to determine that, but I wanted to warn you about that. Now, the link that I give you below, I have made myself. I hope Dying Flutchman doesn't mind, but I've made it myself from his puzzle with conflict highlighting on. And just the killer cages are cosmetic. So you'll get conflict highlighting on all the constraints except for the killer cages, which aren't actually killer cages. So you have to enforce that constraint yourself, but everything else should be enforced for you. So hopefully you won't make the same mistakes as me. And with that, I'm going to send you to past David, who will tell you the name of the puzzle again and explain the rules, and then start solving, and then make mistakes, but he does solve it. So spoilers. So yeah, enjoy. Hello. So today I'm going to be doing a live solve of a puzzle by Dying Flutchman called A Different Approach. And this one, he specifically recommended this one to me for a live solve, so who am I to say no? So the rules of this puzzle, of course, we have normal Sudoku rules. We also have these white dots in between adjacent cells, like here and here and here. And there's a small number inside the white dot. And that number is the difference between those two cells. So just like in crop keys, if you've done those, a white dot means there's a difference of 1 between the two. Well, if there's a number in the white dot, that means that that's the difference between the two. So you take the larger one minus the smaller one, whichever one that is, and that should equal the number in the white dot. Additionally, we have what look like killer cages, but they are not killer cages. So what this means is that within this cage, we take the maximum value and subtract the minimum value in that cage, and that should equal the value in the top left corner. So in this case, both of these have a 3 there. So let's say 7 were the highest digit, and I don't know if it is or not, but if it were, then we couldn't place, say, a 3 in this cage, because then 7 minus 3 would equal 4, and that would be too much. All right, so those are the rules. If you would like to try this yourself before watching my solve, just click the link below. And either way, I hope you enjoy my solve, and I'm going to get started. So the first thing I wanted to think about was what these cages actually mean. So we know that the maximum is at least 7. So like we could have 8 or 9 in here, but it's at least 7. So that means we can't put a 1, 2, or 3 in here, because that would already make the difference larger than 3. So the minimum value in these 3 that we can put is a 4. And of course we could go all the way up to 9. But if we do put a 9 in, then we could only go to 6. So it means that, okay, so because the difference is 3 and there's 4 values in here, it means that all 4 of these are there's 4 consecutive digits in here. So for example, we could have 7, 6, 5, 4. because then the 7 and 4 are different. Or we could do like 8, 7, 6, 5, and then the 8 minus 5 is 3. But if I try to be non-consecutive anyway, like make the 8 and 9, then now I have a difference of 4. Or if I make the 5 a 4, I now have a difference of 4. So whatever I do, it has to be consecutive digits that involve a 7. And then same down here, they have to be consecutive digits that involve a 3. So I could be 1, 2, 3, 4, or I could be 3, 4, 5, 6, or somewhere in between. So there's no 7, 8, or 9 in here. And there's no 1, 2, or 3 in here, I guess is one way to put that. If we ever get another digit in there, that'll narrow it down further. I'm going to look at some of these differences because some of them are pretty large. So like 6 difference, I think, is the largest I'm seeing here. We have that here and here. So for a 6 difference, we could have 7, 1, 1, 7, 2, 8, or 3, 9. So 1, 7, 2, 8, or 3, 9. I might as well put that in. Same here. So what that means is we don't have a 4, 5, or 6. That's still not a lot of information. The other thing that I noticed is whenever we have this donut here, you always have to think of Fist-Mafel's theorem. So I'm going to go over that real quick, and I have no idea if it applies here, but the pattern comes up a lot in these puzzles where people want a clever break-in. So might as well go over it anyway. So I'm going to highlight these orange, and I'm going to highlight these cells blue. We're going to see if this is at all relevant. So Fist-Mafel's theorem, which I'll put a little recommended thing up there to point you to an explanation of Fist-Mafel's theorem by cracking the cryptic. So I'm not going to fully explain why this is the case. But the digits that go in this ring here, or this donut, whatever you want to call it, are exactly the same digits that go into these blue cells. So you can see there's the same number of blue cells as there are orange cells. And the digits are exactly the same. So one obvious thing we can get from that is that there has to be a 7 and a 3 somewhere on this ring, but that's not all at all surprising. But what that does, I don't know, what does that tell us? We know that these are consecutive and these are consecutive. And none of these are directly consecutive, so I wonder if that points us to anything. To be honest, I'm not seeing anything immediate. We'll keep this color just in case it's relevant, but the other thing I'm seeing are these 5s that all point into the center. So the 5 can be 1, 6. Well, we know from XV that basically we just can't have a 5 on a 5. So there's no 5 here, no 5 here, no 5 here, and no 5 here. And there's no 5 here, but we don't know about this cell. We can try it. Really what this would tell us is that the 5 missing in this, if this can't be a 5, this is my motivation, then the 5 missing from this row would have to be in this box, and the 5 missing from this column would have to be in this box, which means that would have to be the center square. So 5 would have to go to -3, so 2 and 8. So we'd have to have a 2, 8 pair here. And then there'd have to be a difference of 4. So both the 2 and 8, so the 2 would go to a 6, or the 8 would go to a 4. So we'd have a 4, 6 pair like that. And so one of these is going to be a 4. And we can't, well, we'd have to, okay, I guess that would make, do I really have to do this? I guess I'll do it. So the 4 difference of 4 would have to be an 8, and the 6 difference of 4 would be a 2. So this is a difference of 5, so the 4 would go to 9 and the 6 would go to 1. The 2 would go to 8, and the 8 would go to 2, so we have another 2, 8 pair there. Let's just keep going around. I'm going to get rid of that. So I wonder if there's an easier way to rule out a 5. I'm just not seeing it. I guess we'll keep going. So this would be a 5 from a 2, or an 8 would be also a 5. So that would actually fill a 5 there. And then then 5 can't go on a 5 difference. So let's just check our work. We don't have to go this direction. So 5 with a difference of 3 would have to be 2, 8. Because 5 minus 3 is 2, and 5 plus 3 is 8. And then difference of 4, the 2 would have to add 4 to make 6, or the 8 would have to subtract 4 to make 4. Another difference of 4, the 4 can't subtract 4, so it has to add 4 to make 8. The 6 can't add 4, so it has to subtract 4 to make 2. And then these are already 6 different, so if we do another 6 difference, that's a 2, 8 pair. And then a 3 difference, we can't subtract 3 from 2, so we have to add, that makes 5. And subtracting 3 from 8 makes 5 as well. And then we can't put a 5 on a 5 difference, because what are we going to put here? Either 10 or 0, and that's not going to work. So that means this can't be a 5. And so as we said earlier, that does put a 5 in the center. Because where does 5 go in this row? So in this row, 5 can't be on the 5. Or here. I guess I didn't prove 5 couldn't be on these two. Shoot. Well, I guess I better do that then. I don't know if this is how I'm supposed to do it, but can 5 go here? No, because we can't change 5 with 6, so that's easy. Can 5 go here? Well, that would make this a 1 or a 9, and that would make this a 2 or 8. And then that would have to go back. Well, no, so that's a 5 difference, so that would be 7 or 3. Three plus 4 is 7. Yeah, so that would be another 3, 7 there. The 3 would have to go to 6. The 7 would have to go to 4. This would be 4 can go to 1, or maybe I should go around the other way. Yeah, this is starting at 3 differences. Yeah, so let's try this other way. So 1, 9, 1 plus 5 is 6, 9 minus 5 is 4. 4 difference here would have to be 8 or 2. Whoops. And then a 6 difference would be another 2, 8. 3 difference from that would be a 5. So this would be 1 or 9. I'm not seeing any problems so far. We don't have the same issue of putting a 5 on this. 6 or 4. And then, again, we have this 4, 6 on a 3. I wonder if proving 5 can't be here is a little bit premature. It's the only thing I'm seeing, though. So 4 minus, so this is either 1, 7, or 3, or 9. Like there's just... But there's a 3, 7 pair here, so this can't be 3 or 7. So that forces a 5 here, just like this 1, 9 goes to 5. So that, again, is a 1, 9 here. We have a 1, 9 pair. That kind of works. I'm sorry if you're seeing something I'm not here. Falling in my chair here. Okay, so that's how you know I'm thinking hard, if I just sink lower and lower into the camera. All right, so as far as I can tell, this actually works. Unless we want to try to use FL to figure out if those can fit in here, but I don't really want to do that. And there's actually 2 ways to do it. Okay, well, we can't prove that 5 isn't here yet. And it might even be here. It kind of works. Can we have 3 5s? So 5 could only be missing from one of these. I mean, we can have a 5 in both of these, and then there's no reason we couldn't have a 5 in both of these as well. So that's not really an issue. Well, I guess 5 couldn't go here because there's a 5 here. So we'd have to have a 5 in all 3 of these. And that does work, as far as I can tell. Well, did I just go down completely the wrong path? I wonder if we can rule out, like, the fact that 5 didn't work here was interesting. I wonder if there's like a weak point along this chain that we can exploit. Like, we know this can't be 7, this can't be 3. So I'm going to mark that we do know that 5 had to be in one of these 3. So if we can prove 5 isn't here, and 5 here is one of these 4. So if we can prove 5 isn't here, then that puts a 5 there. That means, yeah. What was the reason this couldn't be 5? Because we can't do a 6 difference on it. All right. So let's start with these 6 differences again. It's 1, 2, 3, 7, 8, 9. The only thing I can think to do is to just start going around. I mean, can all of these? Yeah, all of these can be affected by this 4, but only in one direction? Yeah. So this is 5, 6, 7, or subtracting from 7, and then downwards we have 1, 2, and 3. Sorry, not 1, 2, 3. We have 3. 7 minus 4 is 3. 8 minus 4 is 4. 9 minus 4 is 5. So we've actually reduced the digit by 1 there. And then here, a difference of 4 actually might... I mean, isn't that going to turn back into... Not necessarily. No, we could add more possibilities. Well, this can't be 3. Which one made that 3? So that was 7. So 7's not possible here, and then 7 for a difference of 6 would have been 1. So that's something. We have the same 4 difference over here, and the 7 was missing. So this is 3, 4, 5, 6, and then we can't be a 3 here. If we couldn't be a 3 here, then on the 6 we can't be a 9. Did I do that here? So we can't be the 7 here. We couldn't be a 3 here, so we can't be a 7 here. So we couldn't be a 1 here. Yeah, I did that. So here there's a difference of 5. So we know this can't be 5 either. So we remove the 5. So that means we can remove the 1, which means we can remove the 7. Okay, maybe this is how we're supposed to do it then. So 5 difference here is going to be 8, 9, or 1. 4 difference will be 5, 4, or 5 again. Okay, so this is 4 or 5. So if it's not 5, it's 4. That's interesting. 3 difference here, so 4 actually can be 1 or 7. And then the 5 is also 2 different numbers, 2 or 8. And then a 5 difference here, we're going to have 6 or 7, or 2 or 3. A 4 difference here is going to be 6, 7. I feel like math is just going to fail me at one point. So these are equivalent. It's interesting. Is that right? Yeah. Because we have two 4 differences in here. And then none of these can go the other direction. All right, a 3 difference here is 5, 6, and then 6 minus 3 is 3, or plus 3 is 9, and then 7 minus 3 is 4. That's too many. We know this can't be 5. We already proved that. We can use that pointing there. So if this can't be 5, this can't be 2. Is that right? Yeah, because 2 can only go to 5. So we remove 2 here. This can't be 6. Yes. Remove 6. This can't be 1. Remove 1. Does that mean this can't be 4? No, because this could still be 4, 7. So that's where that ends. Just trying to look at these pencil marks to see if we're getting any kind of pairs or triplets or quadruples. Not that I see. All right, so we've got 6, 7, 3, and then 6 again. Or 1. 4 minus 3 is 1. 6 minus 3 is 3. 6 plus 3 is 9. Don't want to miss anything. 9 minus 3 is 6. Okay. So now we marry these two up. So 1 goes with 5. 3 goes with 7. 6 goes with 2. So we can't be 6. 7 goes with 3. So we can't be 7. And then 9 goes with 5. So then the other way around, 4 would have to go with 8, so we can't be 4. 5 can go with 9. 6 can go with 2, but we don't have a 2, so that can't be 6. And then 7 would go with 3. So 9 with 5, 3 with... There's probably an easier way to do this. We lost our... No, we have 3. Oh yeah, so 7 can go to 3 or 9, and then 5 can go to 1. Or 9. Wait. 7 can go to 3 and 5 can go to 1 or 9. That's what I meant to say. But this got reduced, so I guess 5 can go with 1 or 9. And then 7 would have to go with 3. So we can't be 2 or 8 anymore. And so now 1 goes with 7. 3 goes with 8. We have 7, 8, so we don't have 9. And then 9 goes with 3, so we don't have 2. Is it possible to not have a 6 in here? I'd have to be 7, 8, 9, and then what? Yeah, so I have to have a 6. Do I have to have I don't have to have an 8. Do I have to have a 5? No. So I can be 6, 7, 8, 9. Well, maybe now that we know how to do it, it'll go faster. I'm basically starting over, but I know there's a 6 here and I know there's a 4 here. So maybe that helps. Oh boy. Half an hour in and I'm starting over, but this 6 is connected here and this can't be a 7 or a 6. So let's just see what that does for us. So this is 1, 2, 3, 7, 8, 9. I'm starting to be skeptical about how I eliminated that 5, but so this is going to be plus 4. So this is 5, 6, 7, or minus 4. So this is going to be 3, 4, 5. But we know we can't be a 6. So 6 minus 4 is 2, so that can't be 2, so that can't be 8. can't be 7 either. So that can't be 3. So that can't be 9. Wow. This can't be 5 either because it's on a 5. So 5 can't be 9 or 1. So 7, 8 is going to be 2 or 1, 2. I'm scared now that I've made a mistake. This is kind of the conclusion we came to last time. We had 4, 8, 2 there. Anyway, 8, 9. And then 4, 5. 8 minus 4, yeah, that's it. So we were mostly correct about this so far as I can tell. This is 1, 7, or 2, 8. Six, 7, 2, 3. Let's go this way. Well, maybe I should just go all the way around. I'm just getting too many results here. 6, 7, 2, 3 again. I remember this. So where did I go wrong? Well, maybe I should just keep 5 in here and see if that gets eliminated in some other way. 5, 6, 3 or 9, and then 4. Too many. 6, 1 or 7, 2 or 8, 3 or 9, and then there's another way to get 6. We almost have everything. So I think I have to start going this way. 4, 5. And then, sorry, I'm paranoid, so I'm like double checking all my work here. 1, 8, 9. I mean, this is all looking familiar to me. Maybe I shouldn't have gone back as far as I did, but I don't know where I made the mistake. And I'm worried it was when I initially rolled 5 out of there. So both 1 and 9 would have to go to, wait, 1 goes to 6, and 9 goes to 4. 8 goes to 3. 6, 1 or 7, and then 3 or 9. This is disappointing. 6 difference. That's going to be 7, 9. 6 can't have a 6 difference. So that's 0 or 12. And then 2, 3. So we got rid of 6. Does that mean we can get rid of 3? I believe it does. Yeah, what else would 3 go to? 4 is 6, so now 5 difference from that would be 9 or 1. So that gets rid of 8 from here. 9 minus 4 is 5. 1 plus 4 is 5. So we placed this 5 again. That forces 2, 8, 4. We know that, like, I'm just going to remove 2. Whoops, undo. I'm going to remove 2 from both of these, because if I place a 2 here, that rules out 2 from this box entirely, and I have to put a 2 in here, and there's no way 7 minus 2 is less than 3, or equals 3. Yeah. Just looking at the rules again to make sure I understand them. Placing this 4 does place this 5. So that forces a 9 here. I'm trying to be careful. Sorry if this is really slow. So this has to go to 8, because it can't go to 2. Maybe that's the problem I did before. So this is 8, 8 minus 5 is a 3. 3 plus 4 is 7. 7 minus 3 is 4. 4 is, this is going to be, well, it can't go back to 7, so this is going to be a 1. 1 goes to 5. This is looking really similar. Maybe this 8 was the only problem. I'm sorry. We can't be a 1 here for, I guess, trusting my marks? I don't know. 7 minus 6 is 1. Let's do 1, 9 here. I don't want to make a mistake. So 1 plus 6 is, well, let's just go from, oh wait, we can do a plus or minus here. So we have the 1, 9 pair. 6 is going to be, what, 7 or 2 or 3? Sorry. Yeah, that meets up with the 4, 6. Yeah, I can't justify removing that 1, so that would have been another mistake, potentially. Okay, so now we know 2's up here. What else do we know? So I had done that logic with 7s, and I think that's still valid. So again, how many 7s can we even have? Is that still valid logic? I think I had a 7 here before. Maybe it's 3s that actually have this logic now. Maybe it doesn't work as well. So we have a 7 here. That accounts for this 7 here. Right, these match up. So I can have another 7, but where would it go is the question. So it would have to go up here. And I don't see a reason that the 7 would not go there. Okay, well, let's actually, I think this is easier. So I may not even have to use Smith file. I'm going to keep the coloring. So 7 can't go here in this box. Where does it go in the box? Well, it can't go in the blue either. So that would make a difference of 4. So 7 goes here, and that points up to here, and that places a 3. So 3 plus 6 is 9. 3 plus 3 is 6. 6 minus 5 is 1. All right, we have our full ring. And it looks a lot better, if you ask me. So what have we got to place now? We have 2 4s. Okay, so this can't have a 4, right? So we did this logic as well. So if we don't have a 4, then we can do either 5, 6, 7, 8, or 6, 7, 8, 9. So let's just put that in. 5, 6, 7, 5, 6, 8, 9, like that. We know we have a 6. Do we know we have an 8 as well? Yes. So we have a 6 and an 8 with a 5 or a 9. Does that tell me anything? Well, it means where do 1, 2... So 1 has... Oh, wait. So 1's out of here. Okay, so this is a 1, 2 pair. Because where do 1, 2 go in this box? Only here. What about 3? So 3 has to go here. We have 4, and then the rest could be in the blues. So this is 3 with whatever is missing here. So this is either 3, 5, or 9, I guess is a way to put that. With having to have a 3. Oh, but there's no 5. Okay. So there's no 5 here, and there's no... Okay, yeah, these 5s look into here. So we actually are not a 9 in here. So clean that up. So So this should also be a pair. What are we missing? We have 1, 2, 3, 4, 5. We need 6 and 7. Okay, can we do the same? So can we do the same down here? We have to have a 1 in the blue because of these two ones. So this has to be 1, 2, 3, 4 then. Got the 3 there. Oh, I thought that was a 3 corner mark, but it's the difference. So 1, 2, 3, 4, 5. So we have 6, 7, 8, and 9 to place. These can't be 7. These can't be 6 or 9. So we have a 7, 8 here. And we have a 6, 9 here. I'm feeling much better about this version. So we're missing a 2 and an 8, it looks like. I'm just looking at how this lines up. And then this is missing also a 2 and a 4, I believe. Yep. We got a bunch of pairs. These 2s line up. Well, I guess that's because there's a 2 here. So what I haven't looked at yet is, okay, well, we placed values on here. So this is going to be 6 minus 4 is 2, or 7 minus 4 is 3. And is any, oh, we have the 2, 4 pair already. So this is 3, 7, 6, 9, 6. Is that all we get? Well, maybe this other one will get us something. So 2 plus 4 is 6. 8 minus 4 is 4. No, nothing. Oh, what was this pair though? 1, 2, 3, 4, 5. This is a 6, 7 pair. So there we go. This can't be 6. So this is 2, 4. All right, I have to go back to when I placed that 2, 4. So that was here, and I decided I had to do 2, 4, which makes no sense. I can be 2, 6, or 8, 4. So that wasn't even a valid deduction to do 2, 4. All right, so what is the next valid deduction? Did I do anything interesting after that? I suppose looking at the 5s, right? So this, I think this still has to be 1, 6, so we can't be 2, 7, or 3, 8, or 4, 9. So this can't be 1, 6, or 2, 7. It can be 3, 8, but can't be 4, 9. And then this 3 actually places 8 and 3. 7, 8. 6, 7. This 6 places 4, 8, 2. Places the 8 up here. Well, I think if I had known highlight conflicts wasn't on, I would have. turned that on, made a new puzzle version for it myself. All right, so I believe we can do these now. So we can be 1, 6. Actually, I think doing this one first was better, right? It can't be 1, 6. Can we be 2, 7? If we are 2, 7, then it's like that. 3, 8. Can't be 3, 8, and we can't be 4, 9. So this is 2, 7. That places this 2. And then over here, we have 1, 6. We can't be 2, 7 because both 2 and 7 can't go here. So that's different than last time. Oh, we can't be 2, 7 because of that as well. We can't be 3, 8 because of this 3, and we can't be 4, 9 because there's a 9 in the box. So we're 1, 6. This 5, 6 pair makes that 1, 6 like that. Okay, what's the next step? I think filling these was pretty fruitful. Well, what's left here? So 1, 5, and 9. This can't be 5 because of the 5, 6 pair. Can't be 1 either, so it's a 9. That places 3, 9. That's a 1, 5, so this should be a pair. 3 and 6. No, not 6. 3 and 4. So that makes this a 2 and 7. Yeah, we did know 7 had to be here already. Just looking for disambiguation there, so nothing. So this is going to be 2, 5, 6, or 9. These can't be 6. These can't be 2. These can't be 9. So this is 2, 9, and 5, 6. 5 C's down here. 6, 5. Any bets on whether I break it again? I don't know what the going rate is. All right, 1, 2, 3, 4, 5, 8. So 1, 4 is seen there. Whoop. What did I do? All right. So this is 5, 8. I remember that from last time. This should be placeable. It's a 1, 2, 3, 4, 4, 5, 6, 7. It's a 9. Yeah, it's a 9. And then these two are 5 and 8. This is placeable. 5, 8. Wait, no. Oh, no. Yeah, this is the 1, 4. Not allowed to break this again. All right. Okay, what goes here? Wait, did this 5, 8 do anything? Yes, the 5. We get the 6, 5, 1, 6, 2, 1, 4, 2. I think that's where that ends. So there's 2 left in each of these rows. This is 3 and 7. That's disambiguated. And this is 4 and 9. Not seeing how that gets disambiguated yet. This 8 C's over here, 5, 8. Placing those do anything? Okay, so we haven't done anything with the center box, I think because I undid all of my work there. So we can place a 5, the only place where it goes. Okay, well, there's only 3 left in this row, so let's fill those. 4, 5, and not 5, 4, 8, and 9. This is not 8. This is not 8, so this has to be the 8. It's the only where in the row that an 8 can go. About 4, 9. We got a 4, 9 pair, so this is 2, 9. What are these two then? 1 and 3? No. 4, 5, 6. 1 and 6. Oh, this 4 C's here. So 9, 4, 9, 4. No deadly pattern this time, please. This one's a 7. Make sure I get that right. It won't tell me if I'm wrong. 1, 2. This is the 2, 3 again, but it's not deadly this time. And I should have something disambiguating all these. So I got 5, 8, 9, 7. Yeah, so 2, 7, 3, 2, 4, 3. Ooh, what am I? The 6. So 1, 4, 1, 6. And these two as well. Yes, 1. This is 1, 4, 5, 1. Okay, I think that's the right answer. I hope it's the right answer. It looks good this time. All right, well, definitely. I think that if I'd caught my mistakes earlier, this really wasn't a super difficult puzzle. I just made so many mistakes because I'm me, I guess. Hopefully you didn't have as much trouble with this. And I think I'll put a little message at the beginning. Should I put a message at the beginning? Yeah. I'll put a message at the beginning clarifying that I've changed the link from what you're seeing here and warning you that I make several mistakes in Undo. And I don't think, I think I'll maybe fast forward some of the sections. I'll try. You'll know more than me at this point whether or not I succeed at that. But either way, I did like the puzzle, Dying Flutchman. I'm sorry I made such a mess of it. Completely my fault, not your fault at all. This was a great puzzle. I really enjoyed it. I actually don't think I think the only thing I really used with the Fistamafel was maybe the 7s and 3s, but I think I did that when it was wrong. So I don't think Fistamafel was actually needed, but it was an interesting highlight to have the whole time. So anyway, I'll put some boxes on the screen for some other videos in case you want to watch some more of my videos. If you want to see more, hopefully not quite as mistake-filled live solves in the future, make sure you subscribe so that you can see those appear in your feed. I also post highly edited videos of good solve paths for puzzles that I create. So some people find those more interesting, some people like the live solves. Go ahead and taunt me for how much better you did on this puzzle than me. My time at this point was probably around an hour and 17 minutes to solve, so I'm sure you did better than me. I don't profess to be a great solver, I just have fun doing it. So I hope you do too, and I hope you learned something from this. At the very least, you learned that perseverance is key. If you want to solve these puzzles, don't give up. You can always undo. All right, and until next time, thanks for watching.